Dear students, I am Kavita BS, Assistant Professor, Department of Physics of Government First Grade College, Tiptur. In this session, I will explain how to calculate the atomicity of monoatomic gas molecules. This topic is in BSc course Physics subject, paper 3rd, Thermal Physics, Radiation and Optics 1. And this topic is in the lesson Thermal Physics of Unit 1. Let us start the discussion. In general, the atomicity of gas molecules can be defined as the ratio of specific heat capacity at constant pressure to the specific heat capacity at constant volume. That is, atomicity of gas molecules is equal to Cp by Cv. In order to calculate the atomicity of gas molecules, we need to know the values of Cp and Cv. For that, let us consider the degrees of freedom of monoatomic gas molecules. The degree of freedom of monoatomic gas molecule is equal to 3 and is due to translatory motion. Then, according to law of equipartition of energy, the energy associated with each degree of freedom of monoatomic gas molecule is equal to half kT. Then, the total energy associated with 3 degree of freedom is equal to 3 times of half kT. Next, the total energy associated with 1 gram mole of a gas is equal to 3 by 2 kT times Na. Here, Na represents Avogadro's number, T is the absolute temperature and K is Boltzmann constant value. Here we are substituting the value of K into Na as R. Here the product of K and Na represents universal gas constant, that is R value. Then on substituting in place of K into Na by R, we get the energy associated with 1 gram mole of a gas is equal to 3 by 2 RT, and it is represented by the letter U. Then finally we get energy associated with 1 gram mole of a gas is equal to 3 by 2 RT. Then next, on differentiating this with respect to T, we get du is equal to 3 by 2 R into dt. Rearranging the terms, we get du by dt is equal to 3 by 2 R. Here, du by dt represents Cp value, that is specific heat capacity at constant volume. Then, by substituting the term Cv in the place of du by dt, we get Cv is equal to 3 by 2 R, that represents specific heat capacity at constant volume, that is heat required to rise 1 unit mass of gas through 1 unit of temperature. Then that at constant volume, that represents Cv value, that is Cv is equal to 3 by 2 R. Then next, also from Mayer's equation for ideal gas, we have Cp minus Cv is equal to R. This is from Mayer's equation. Then on substituting the value of Cv in this equation, we get Cp value, that is Cp is equal to 5 by 2 R. Then again, by taking the ratio of Cp to Cv, that is specific heat capacity at constant pressure to the specific heat capacity at constant volume, we get 5 by 3. Again, on further simplifying this stuff, we get 1.67. So this value gives the value of atomicity of monoatomic gas molecules. So by this simple calculation, we can calculate the value of atomicity of monoatomic gas molecules. These are the textbooks for your reference. Thank you.